milliliters of a solution that's 15% acid. The question is, how much of the 70% acid solution should be added to create a solution that's 60% acid? Lots going on in there. Okay. What I will tell you is the end result here is I want to have my new amount of acid over total equal to 60. So I'm going to reserve that 60 for 60% because that's going to happen at the end. Okay. So originally, guys, can you find for me the amount in milliliters of the original solution? Very nice. Originally, there is 12 milliliters. What percent acid is that original solution? 15%. So if I wanted to know the amount of acid, what I could do is I could take 15%. We all agree, hopefully, that 15% is 0.15. And I could multiply it by 12. Okay. Can you tell me what that is? Good. All right, so we have our original. If we were to break it down, I know a mixture doesn't work like that, but if we were able to separate that mixture, 1.8 would be like pure acid out of that whole solution, okay? Now, the question is how much. In math, when we say how much, that's typically where I put my variable. I am adding some in. I don't know how much. So I'm going to make what I add x, okay? If I don't know how much it is, would you agree then the final solution would be 12 plus x? Okay. All right, let's go back up to the amount of acid. Once again, this is going to be in terms of x. The thing I'm adding in, what percent acid is that one? 70%. So I'm going to write 0.7 times x, because if whatever that amount is, 70% of it is acid. And now I'm going to write my new total. My new total is just going to be adding those two together. So I have 1.8 plus 0.7x. Do we have any questions so far? Okay. Let's go back to my original setup. The new substance, I'm going to take the amount, my expression for the amount of the acid over the amount of the total, and I want my new mixture to be 60% acid, so I'm going to set it equal to 60%. So we have 1.8 plus 0.7x over 12 plus x, and that has to equal 0.6 or 60%. So the reason why I think these ones are a little bit easier is because there's the solving part is quite easy. There's only one fraction. I multiply by what? 12 plus x. So I multiply both sides by 12 plus x. What happens here? They cancel. I have 1.8 plus 0.7x, and then I distribute. What's 0.6 times 12? Good. 7.2 plus 0.6x. All right, at this point, we're in Algebra 2. I'm not going to insult your intelligence. Let's just use our brain. We're going to move all the x's to one side and all the other stuff to the other side. If I took this 0.6x away from 0.7x, wouldn't you agree? On this side, we would have 0.1x. Okay, over here, can you guys take 7.2 and minus 1.8? do you get 5.4? What now? Divide both sides by 0.1. X equals 54 milliliters. So how much of the 70% acid should be added? 54 milliliters would be the answer to that. Okay. Let's just do setup on the next one. I think the solving part is review, and then we'll go to a work problem. All right, so I'm going to give you a second to read. If you feel like comfortable working ahead because you think you'll understand, go for it. Okay, that second underlined is the original amount. There's 15 milliliters here. It's 10% fruit juice. So the amount of juice, 0.10 or 0.1 times 15 is 1.5. Are y'all with me? Okay. I do not, once again, I don't know. I'm trying to figure out how much to add in. You can use J for juice if you want. I'm going to add in X. What that means is my new solution is going to be 15 plus some unknown amount, X. What's the percentage of juice of the thing I'm adding in? 65. So the amount of juice in that one would be 0.65x, and the expression for the new would be then 1.5 plus 0.65x. So my setup for this one is I want my new solution to be 35% juice. So I would take the amount of the substance, 1.5 plus 0.65x, over 15 plus x, and I would set it equal to 0.35. So that's the setup there. And then you could go from there. Okay. Then, work problems. Okay, so here's how work problems are a little bit different. The idea is this, that just like we had distance equals rate times time above, if you think of a rate is like today in these work problems, how long it takes you to do a certain job, okay? So that job could be raking the leaves of your yard. That job could be draining a pool, okay? But it could be painting a room. If I want to figure out the rate, just remember we're going to take one job, whether it's that pool, that room, that yard, and divide it by the time. So that's the premise there. There's going to be an X involved though. All right, so drain 1. Locate drain 1, please. Drain 1. How long does it take drain 1 to empty the pool? I'll call this one drain 1. One pipe can drain the pool in 3 hours. So it's going to go do one pool per 3 hours. That's what I mean by one job, one pool. Now, do you need, that's really what I'm doing, but when I do the math, I'm not going to put the word pool in there. Okay. Drain 2. One pool in 5 hours, right? My question is, if both drains are open, how fast can the pool be drained? They're combined. I don't know, right? What do we put when we don't know? One pool in X hours. When you're solving these types of problems, sometimes it's the combined rate that's unknown. Sometimes it's one of the other rates that's unknown. So sometimes the X will be in the combined part, sometimes it will be with one of the things or the objects or the persons. Would you agree though, if both drains are open, aren't they working together? So the combined rate should be this rate plus this rate equals my combined rate. What are we going to multiply both sides of that equation by? Well, I need a 3, I need a 5, and I need an X. I got to do all of them. We'll put that together. 3 5x makes 3 times 5 times x makes 15x. All right. $15x divided by 3 is 5x. 15x divided by 5 is 3x. Over here, the x's cancel, so you're just left with 15. Can you finish that for me? What did we get? Um, 1.875 hours to drain the pool is what I got.